You ever look at a huge, messy problem and just think, where on earth do I even start? Well, it turns out the answer is often hiding in plain sight, just buried under mountains of data. Today, we're going to see how a really structured process can take all that chaos and turn it into crystal clear solutions. So let's frame the problem.
And I mean that literally. What if your company was bleeding millions of dollars every single year from one stubborn issue? Figuring out the why isn't just a thought experiment. It's a high-stakes puzzle with a massive payoff. For colleges and universities, that million-dollar headache has a name: student attrition. Every time a student drops out, the school loses tuition money, sure, but also fees and even future donations from alumni. It's a huge financial hit. And this is the exact problem we're going to crack today by following the breadcrumbs left in the data. So the first big question is, what clues do students leave behind before they decide to leave? And how in the world can we gather all those different pieces of the puzzle to see the whole picture? Step one is just figuring out where all this data lives. And the answer is pretty much everywhere. For a university, you're pulling student grades, attendance records, maybe even looking at their activity on online learning portals. You gather all of it, centralize it, and get it ready for the next step, which is honestly the most important one. Okay, so now we get to the part that isn't exactly glamorous, but it is absolutely critical. See, you can have all the data in the world, but if it's a total mess, it's completely useless. This part is all about taming that data beast. And this quote right here, it nails it. Real-world data is not some perfect, neat spreadsheet. Nope. It's full of typos, missing pieces, and all sorts of weird inconsistencies. Before you can even dream of finding patterns, you have to clean it up. Seriously, whatever you do not skip the cleanup. So, how do we do it? Well, there's a structured process. First, you consolidate, you bring it all into one place. Then you clean it, fixing the errors and filling in the blanks. After that, you transform it. Maybe you normalize the values, which is just a fancy way of saying you put different kinds of data on the same scale so you can compare them. And finally, you might do some data reduction to zero in on only the most important pieces of info. It's a four-step journey from total chaos to clean, useful data. All right, our data is clean, it's organized, and now we can finally get to the fun part, building our analytical toolkit. This is where we stop just looking at what happened in the past and start using data to find hidden patterns and maybe even predict the future. You know, business analytics usually gets broken down into three main buckets. Descriptive analytics tells you what happened, predictive analytics tries to forecast what will happen, and prescriptive analytics actually recommends what you should do about it. For our problem, we're really focused on that leap from descriptive to predictive. Let's make this super clear. A descriptive approach might tell us, hey, historically, 20% of our first-year students drop out. Okay, that's interesting. But a predictive approach tries to tell us which specific students are at high risk of dropping out next semester. See the difference? That's the leap that lets us actually do something about it. And the tool that lets us make that leap? It's called statistical modeling. Sounds complicated, but the idea is actually pretty simple. It's just using math to find and describe the relationships that are hiding in our data. A model can tell us if there's a strong link between, say, a student's GPA and their chances of sticking around. So, let's bring it all back home to our university's million-dollar problem. We've got our clean data, we've got our predictive tools. Now it's time to actually apply our models and see if we can solve this retention puzzle. This visual here really lays out the whole roadmap for us. You can see the raw data coming in, going through that all-important cleaning step. And then the analysts test a whole bunch of different models, things like decision trees, which are basically just a series of if-then questions, or neural networks, which are kind of inspired by the human brain, all to see which one is the best at predicting who might leave. But just when you think everything's going great, a hidden trap pops up. It's called the data imbalance problem, and it's the kind of thing that can completely wreck your analysis if you're not looking for it. Okay, so check this out. Let's say 80% of students stay in school. That's the no case, they don't drop out. And only 20% leave, the yes case. Well, a lazy computer model can get 80% accuracy just by guessing no for every single student. On paper, 80% sounds amazing, right? But it's completely useless because it fails to find the very students we're trying to help. And this comparison shows the solution so perfectly. Look on the left. That's the result with the original unbalanced data. The overall accuracy is high, like 87%. But look closer, it's terrible at predicting the students who actually did drop out,
less than 50%. Now look at the right, after they balance the data. The overall accuracy is a little lower, sure, but the model is now correctly flagging almost 75% of the at-risk students. It became a less accurate, but infinitely more useful model. That's the whole ballgame.
So, we've cracked the student retention puzzle. But the really exciting part, the thing that gets me fired up, is that this exact same structured approach is changing the game everywhere, in pretty much every industry you can think of.
I mean, this is about something completely different, like trying to predict college football games. It's the same exact process. You gather data on team stats, you clean it up, you build different models, and you test them. The data's different, but the fundamental logic is identical.
So if there's one thing you walk away with today, let it be this 5-step process. You start with a clear problem. You gather all the data you can get your hands on. You meticulously clean and prepare it. And remember, this is the most important step. Then you build and test your models. And finally, you look at the results not just for accuracy, but for how useful they are in the real world. This is the blueprint for turning data into decisions.
And that brings us right here to the final question for you. We've seen how this process can save a university millions and even predict sports games. Now that you've got the blueprint for moving from chaos to clarity, what problem would you solve?